Folks, so let's continue to talk about problem theory. So now we're going to discuss about this grand Monty Hall problems that basically say we have a single price behind a car, behind the doors. The price is the car, and people open the door from one to three and trying to find a car. Um, um, the choice is just one first. Then the game show house open the door and reveal nothing. And now the question is, would you rather choose the another door while you stick to the existing door? So let's look at it. So you, for example, choose the door one, which let's say that there is a car, and then now the host open the door number three, which reveals nothing. Would you choose to change the door? If you switch, basically lose game. If you stay, you win the car. The same for the number two. Door number two is car. You choose number one, and now host choose door three. It's empty. If you switch, of course, you have a probability to win. If you stay, you will lose. Um, and yeah, so well, there is the case that door number three, that in this case, the host won't reveal the door number three, but in this case, host will open door number two, so to say. Um, it seems no difference for many people, but in fact, it actually, for me, it is sort of intuitive because we are choosing the door that has no price with the prior knowledge that host has. And to show we use Bayesian, let H note happens that the price behind door I. Okay, let's just do this way. And after choosing door 1 is either y3 is y2, meaning the door 2, 3 is open respectively. Assume that two possible outcomes have the following possibility. So given that there's a price, and door number 2 is that probability 1 divided 2, and price 2 given by the door number 2 is 0. The probability of the price 2 given that door 3 is probability of the 1. And saying that the likelihood of door 3 given by the price behind door 1 is loaded 1 times 2. The probability of the door 3 given by the price number 2 is 1, and the probability of the 3 given. Yeah, so basically, it's intuitive. Like, that already, if you open door 3 and there's nothing, there is no price. Same goes here. If you open the door number 2 and there is no price, then there is no price. There's no possibility. So you have a possibility that you know it. And now using the theorem, so like whatever the um, possibility of the state. So the price is behind the door possibility, given that y equals 3. Given that the door is open for 3, is that the probability of the door is open 3 given by this hidden state times the probability of this hypothesis that the price is behind door divided by the fact that the probability of the y equals 3, so the door is open for 3. And you just calculate all of that, and what you got is probability of h1 y3 is 1 times 3. So this is probability that given door 3 is open, and what's the probability of the price behind h1 is still 1 to 3. What the probability of h2, the price in h2 given by the probability y3 is open is now 2 divided by 3, and there is zero chance that the price is behind the probability of door number 3. So what it means that it's better to switch to door two, simply because that we have this mathematical notation, but also sort of intuitively, if you ask the host to choose the empty door, he knows where the prize is, so at least he make a contribution to your sort of decision that he choose the one that doesn't have the card. So it even intuitively you sort of say like, okay, so he now contributed to the fact that he choose the door which doesn't have the card. So I would rather change the choice because that add up the contribution that the host choose. So even if you choose the door that has a car behind it, um, well, it's like aggregated values, right? Like, of course, if you choose the door that has a car already, um, the opening the empty door from the host might not be the best solution because if you switch it, you basically lose it. However, if you choose the door that doesn't have the car behind, then the host open the door that doesn't have the car, make a definite contribution for your decision because you simply get one more empty door for your decision making. So when you switch it, you basically getting the host one divided by two sort of idea on top of your prior decision. Hope it does make sense. Like for me, it's completely click the idea, but you can also Google what the Monty Hall problem is, and it will tell you all about this Monty Hall stuff. Um, Let me think about it so I can also pick it up this quick. Mm, there you go.